Welcome to the OpenGL Primer, an introduction to OpenGL and OpenGL programming. We'll start with a simplified model of your programming environment. The lowest layer in this model is your hardware platform or your computer. There is also another hardware low-level layer in this model, and this is your graphics card, your graphics hardware, including the GPU, the graphics processor unit. On top of these two layers is sitting the operating system, which works directly with both hardware platforms. There is also the graphics API, which is a software component collaborating directly with the graphics card. Your typical game engine is sitting on top of both operating system and graphics API, and on top of all this is sitting your game, which most commonly is communicating with your game engine, is using your game engine actually, but it is also communicating directly with the operating system and sometimes with the graphics API. This is the graphics API that is the main subject of this module, or in fact the 3D graphics programming part of this module. There's also another module, the professional game development environments, which is mostly focused on the game engines. Now, the typical graphics APIs are OpenGL and DirectX, and from among these two we will be talking about OpenGL in this module. Typical game engines are Unreal and Unity, and they will be both discussed in the other module. First proposed name for this module was low-level game programming. So we will be looking at 3D graphics or game programming at a very low level, close to graphics hardware. We'll be considering the API, which stands for Application Programming Interface. This is an interface for you, the programmer, the interface to the graphics hardware. There are two main standards, as I mentioned: the DirectX, proposed or produced by Microsoft, and it is primarily used in Windows and on the Xbox platform, and OpenGL, which is also available in Windows, but also nearly everything else except Xbox. If we have all those excellent game engines such as Unreal, Unity, what's the point to program at the low level? Is it easy to implement, rapid in development, helps understand your hardware, flexible, effective, fast, provides features not otherwise implemented, provides cutting-edge technology, extends your engine, platform, creates or allows you to create a new engine or migrate to a new engine? The answer is all of these except the first two. It's neither easy nor rapid, but knowing how to program at the low level, you will well understand your hardware, and this will also support your understanding of the game engines. It's flexible because at the low level you can do everything. The only boundary is your skills and imagination. It's effective, of course, not in the time of development, it's in the time of execution. It's very extremely fast, couldn't be faster. This gives you unlimited access to the features that might be otherwise not implemented in your favorite game engine. Of course, it's a cutting-edge technology. Of course, you can extend your engine or platform. You can even create a new engine. And an important reason also is if you understand the low-level programming, then migrating to a new engine should be easier for you because you will know all the principles behind this engine. Okay, in this module we'll mostly concentrate on OpenGL. So some facts about it. This is a cross-language, multi-platform API for 2D and 3D graphics. It provides an interaction with hardware-accelerated GPUs. GPU stands for Graphical Processing Unit. It is possible to implement in software, but OpenGL has been designed to be implemented in hardware. And actually using software emulators is nearly pointless, mostly because they are terribly slow. Its predecessor, called IrisGL, was released in 1982, but the name OpenGL for the first time appeared in a product by Silicon Graphics in 1992. It is an open technology, but not open source. What does it mean? This means that OpenGL is managed by Khronos Group, and Khronos Group is a consortium that is open for any participant. But the consortium do not provide any access to the source code. OpenGL is currently in version 4.6, and this version is the current one since 2017, and it also has already its successor, and this is the Vulkan system, which is much newer, much better. And we will not use this system in our module because, well, it's not a very good system for beginners in 3D technology. If you are interested in a discussion why OpenGL should be used to teach 3D technologies and not Vulkan, you have this link here, and it should appear somewhere in the description of this video. A few words about the Khronos Group, because this name appears quite often when you work with OpenGL. So it started as an ARB, or Architecture Review Board, in 1992 and changed its name to the Khronos Group in 2006. Since then, it controls the OpenGL specification. This is a non-profit technology consortium, and it is open in the terms that any company working in the 3D area can join. OpenGL working group within Khronos is still known as ARB, so this name is still around, and members of this organization include AMD, Apple, ARM, Creative Labs, Ericsson, Google, ID Software, Intel, Motorola, Mozilla, Nvidia, Oracle, Samsung, Sony, and Texas Instruments. So most of the important corporations in the area of 3D. But, and this is quite an important bit of information for us, Microsoft left ARB in the year 2003. There's a number of games and other programs that include OpenGL renderer, but it has to be stated that most PC games are developed for DirectX, the Microsoft system, or the counterpart of OpenGL, another competitive graphics API. When Microsoft introduced Windows 95 in 1995, so not so long after the beginnings of OpenGL, they also proposed DirectX, which was then called Wing for Windows Games, to encourage writing games and playing games in Windows 95. It is a proprietary framework from Microsoft, and this is for Microsoft platforms only, so basically Windows and Xbox. DirectX provides support for 2D and 3D graphics, but also sound, media, and GPU computing. Why does everyone use DirectX? Why it's kind of more popular than OpenGL? First of all, because of DirectX and Xbox very strong marketing campaigns. There is a positive feedback effect, so the more people are using DirectX, the more popular it gets. The more popular it gets, the more people are using it. And so on, so on, so on. So it's a self-propelling system. Also, there is a lot of misleading marketing. Microsoft is guilty of spread of fear, uncertainty and doubt about OpenGL, including fake news about OpenGL being discontinued or totally failed technology. Eventually in 2003 Microsoft left ARB, and OpenGL is formally no longer supported on Windows. So OpenGL, compared to DirectX, has less vendor support, is actively attacked by Microsoft, is less often used in games, has a smaller marketing momentum. So why do we still want to use it? And I have 3 good reasons for you to use OpenGL. First of all, OpenGL is more powerful than DirectX. Not just faster drawing functions, but also OpenGL developers are always the first to access the new GPU features, whilst developers, depending on DirectX, only are delivered with occasional snapshots with basically Microsoft update cycle. The point is that every new GPU comes to the market with a ready set of drivers, and these drivers include everything that OpenGL needs to run on the new hardware. Also, and perhaps it's more important even, OpenGL is cross-platform, so it's also Linux, Apple systems, Android, WebGL, so web-based version, and so on, so on. OpenGL is generally better for the future of the games. It's a non-profit open standard, and it provides the highest quality graphics that the hardware can provide. Also, we have to keep in mind that OpenGL is in fact, as an industry standard, it's currently being replaced by Vulkan, and Vulkan provides a new level of quality, which is comparable. Of course, you may discuss it's comparable to DX12, for example, but first of all, it's open, it's cross-platform, and it's powerful. Besides of that, if you learn just one framework, you will understand the principles of the 3D graphics, and if you understand 3D graphics, you will easily learn any other framework. For example, Vulkan. Okay, so what's included in OpenGL? First of all, graphics, and that's number 1 on the list, and that's also the end of this list. OpenGL is strictly a graphical API. Pure graphics only, no high level, no math functions, no OS support, no I/O, no sound. All this is not included, just not included. And even few functions that were supported are being gradually removed as deprecated functionality. So for everything that is not strictly pure graphics, you will need to use some kind of other API, other library, third-party stuff to run. There is a lot of possible options here, and quite many of them have been designed specifically to support OpenGL, but they are technically not a part of OpenGL. So, to summarize, purely platform independent, multi-platform, Windows, Unix, macOS, iOS, whatever you want. And we also have OpenGL ES for embedded systems, which covers such platforms as iOS, Android, WebGL, consoles, most consoles except of Xbox, of course. And language independent, so OpenGL works very well with C, C++, C#, but also Java, JavaScript. Okay, some a few more facts that you may not be entirely sure how important they are right now, but very soon you will recognize them as actually a crucial thing about OpenGL. So today, just a quick introduction. OpenGL is evolving, currently in the version 4.6, and its architecture is extensible. So GPU vendors provide extensions that provide specific functionality for the newest hardware. Some extensions are then adopted by other vendors, and finally the ARB, which we remember is now a part of the Khronos Group, may promote these extensions to the core specification of OpenGL. But we also have the other model which works the other way. So this was about how the architecture can be extended, but we also have a very strong deprecation model. So this is a model for removing parts of the API or cleaning OpenGL up of the old functionality. A deprecated feature shouldn't be used in new software, but it will be still supported for some time. And even if some deprecated features would eventually be removed completely, they can still remain available as extensions thanks to the extensible architecture. So, as I mentioned, Microsoft is not any longer supporting OpenGL. Windows provides implementation for the version 1.1 only, which is, of course, absolutely outdated. Okay, basically, Microsoft don't love OpenGL. So what? The implementation you need is provided by the GPU manufacturer in the form of your graphics card drivers, and this is thanks to the extensible nature of OpenGL. So, yeah, that's a very smart architecture of OpenGL. This architecture luckily started in the version 1.1, so Windows left or abandoned OpenGL in a very crucial moment, in the moment when OpenGL started to support extensions. Therefore, when you install Windows, you get DirectX version 1.1. Then you install drivers for your graphics card, and these drivers include extensions for OpenGL, which upgrade your version of OpenGL to the current version, well, appropriate for your graphics hardware. So if this is a latest graphics card, this will probably be OpenGL 4.6. And from the point of view of a developer, a situation is simple. Upgrade to the latest graphics drivers and enjoy your adventure with OpenGL. So, I assume that most of you have, well, decent graphics card. It's very much recommendable that you update your graphics card drivers before you start continuing in this module. If you have done this, you are guaranteed to have the best version of OpenGL without anything else to be installed. So what you need to program OpenGL, not DirectX, OpenGL, it's Windows and your latest graphics card drivers. That's it. Okay, there is one more important topic to discuss, and this is so-called fixed functionality and programmable pipeline. What are fixed functions? Fixed functions are what was initially developed for OpenGL in the 90s, so long history ago. They are not very flexible, but very easy to use. They can't use the full potential of hardware-accelerated GPUs, and these fixed functions, with a few exceptions, are deprecated, so they are removed, in the process of being removed from OpenGL. and they are replaced by the programmable functionality called programmable pipeline, in which the essential stages of the graphical pipeline are implemented directly in the hardware. And when I say directly in the hardware, I mean the GPU, the graphics processing unit, or the main processor of your graphics card. So the exact situation is that a OpenGL program delegates the essential stages of rendering directly to your graphics card, and those programs that are delegated to the graphics hardware are called shaders. A shader is a program to be performed by the GPU in contrast to the CPU. GPU is the graphics processing unit, CPU is the central processing unit, so CPU is your main processor. Actually, if you would kindly look at your personal PC which you are using to program your projects, inside you have at least two very powerful computers. One is based on the CPU and your main motherboard, and it does everything like Windows, games logic, and so on and so on. And the other, the second computer, which in some cases, for example in the case of the computers located in our computer lab at the university, this other computer will be computationally more powerful, and this is the GPU, the heart of your graphics card. And this is what OpenGL addresses. This is what we will do in this module. We will be writing shaders, and we will be using a language called GLSL, OpenGL shading language, a special language for programming the GPUs. Don't worry, this language is quite similar to C, so it's not a completely different skill. But well, it is quite a new, quite a lot of new things to learn. All right, as I mentioned, fixed functions are to be deprecated. So in this module, for just a short period, like a few weeks, we'll be using fixed functions because they are easy to understand, they are easy or fast to implement, and they are sometimes quite essential to introduce some basic concepts. For example, if you participated in the first workshop in the 3D programming series, the one entitled Your First OGL Project, in which you started with rendering a triangle, and then if you advanced this further, you got a rendering of a teapot. These projects were using fixed functions, entirely fixed functions, but a lot of functionality in this code is now deprecated and shouldn't actually be used. So for most of the time, so in a 3 or 4 weeks, I'm not exactly sure at which moment you will watch this lecture, of course. But for most of the time in this module, we will be working on the programmable pipeline, which is absolutely necessary for all advanced special effects, and that's the only practical reason that you would like to go down to OpenGL programming and do something low level when you can use an engine, okay, a game engine. So the reason to learn OpenGL is to learn how to write shaders, how to program graphics hardware directly. And with this bombshell, we are arriving to the takeaway messages. Our main learning objective in this part of the module is to get as close to graphics hardware as possible. We'll be writing shaders or programs running directly on the graphics card's GPU. OpenGL is good for it because it's open and it's cross-platform. We are not using DirectX because it's proprietary and Windows or Xbox only. Otherwise it's not bad, but remember, it's Microsoft. Vulkan is excellent, but the learning curve is so steep that it is not a very good idea to learn it in an introductory 3D graphics programming course. Well, and in Windows, we can use the latest versions of OpenGL thanks to the ARB extensions. Microsoft has abandoned support at the version of OpenGL 1.1, but the latest version will arrive with your graphics card drivers. This is the end of this introductory lecture. Thank you very much for watching, and I invite you to the next lecture on transformations and matrices. Goodbye.